In this case, the main idea was to create a parking lot in a more efficient way, using infrared sensors to automate access to the parking lot and to prevent access when it is at its maximum. This can prevent future accidents and parking congestion. In addition, various components were used, such as servo motors, LED and potentiometer, jumpers, breadboards, and an Arduino.
For this project, the code consists of 8 parts. For the first part, we have the declaration of the near variables for all the components and the information to be stored. Also, the addition of the servo motor library. Then we have the declaration of the pins in the Arduino, using each component with the addition of the serial monitor and the initial position of the servos in 0 degrees. The next part is the reading of the information provided by the inputs, in this case the potentiometer and the 2 sensors. After that, we have 2 important instructions, which are the limit we put to the potentiometer in order to cover the required angle for the servo, 0 to 100 degrees, and the turning on of the yellow LED in order to show the bands of the cars entering the parking lot. Then we have the conditional that controls the red and green LED, with the instructions that if the number of cars is lower than 50, then the LED green would be on, but if it's greater, then the red LED would be on, marking that the parking lot is full. For the next part, we have the conditional for the entry of the parking lot, showing that the servo will be only activated if the sensor is detecting a car and if there is space on the parking lot. Furthermore, we also modify the variable of cars and bright to show that a car has entered the parking, and we print in the serial monitor the number of cars that the parking lot has.
In the case of the exit, we have the condition that the sensor needs to detect movement, and if it is, then the servo will be active with the help of the potentiometer. In addition, we modify the variable of cars and bright to show that a car has left the parking lot, and we printed in the serial monitor how many cars the parking has. For the last part, we finish the code with an else, showing that if none of the above conditions apply, then the servo for the entry will be closed, and the code will repeat itself until a condition is met. As we can see, the circuit in this project works by using infrared sensors to open the servo motors at 90 degrees. Also, as mentioned in the code, every time a car is detected, it is stored in a counter as seen below. After this, in the exit of the car park, the operation is different, because for the car to exit, the sensor must detect a car and the potentiometer must be controlled. We also have 3 LEDs, which ideally indicate the parking status. The green one indicates if there is space for another car. The red one indicates that it is full, and the yellow one varies its intensity depending on the capacity of the parking lot.
In this case, we were able to learn a lot about the usefulness of the topics we have seen so far. They allow us to properly automate various systems. It is essential to emphasize that teamwork was fundamental for this project. As it was a project that consists of many parts, it was necessary to assign roles and support each other during the creation of the project.
In the end, we believe that several parking saturation problems can be solved because automated parking systems really contribute to increased parking capacities in urban areas, where space is often limited and traditional parking solutions may struggle to keep it up with demand.
My contribution to this project was in the creation of the model, in addition to helping in the process of connecting the electronic elements and reviewing the connection of each component. In the process, I learned how to connect a potentiometer and a servo motor. Additionally, I also learned how to program both components. I think what I liked most about the project was connect all the components to our model in a way that was functional. Personally, I consider the most complicated situation to be the functioning of the components together, as individually the components work, but not when connected.
My main contribution in this project was the developing of all the code, but I also helped in a small size to the construction of the parking lot and the connection of the electronics. During this project, I learned the importance of the organization, either of the team but also for the code, and I was able to learn how to program different electronics, such as the servos and the potentiometer, especially with the values they read. And also, during this project, I really like seeing how could we apply our knowledge to a real-world situation. In addition, I really enjoy working with my team and the challenges we face together. The most challenging part was the union of the code for each one of the elements, since individually we were able to make the components work, but when we tried to put it all together, it was difficult to make it.
In my case, my major contribution to the project was to do most of the electronics. I also helped a little bit with the code and the model. Through the development of this project, I learned about the importance of teamwork and the fundamental role of code in this type of work. I also learned how to control a servo motor with a potentiometer. And for me, the thing I liked the most was the creation of the model. By the way, it was a really interesting challenge to make the code work. For the same reason, for me the most complicated part was the code section, as we managed to make all the components work separately, but it was a real challenge to make them work at the same time in a single code.